All right, so we can go ahead now. All right. But so just for the benefit of persons who don't know, I'm going to explain what a frequency table is all about, right? Now, what I'm going to ask you to do, okay, is to see if you can create a frequency table for this data. Can you see it properly? Frequency.
Yes, sir.
All right. So you go
You
ahead.
can zoom a little bit.
I can zoom in, zoom in.
No, sir, me not see top number them.
You see it better now?
Yes, sir.
Okay. But for those persons who are viewing on the YouTube channel, where they can go ahead and construct a group, a frequency table for this set of data here being collected. So we'll do it for on group, and then we'll also do it for group data.
So I'm for the ungroup first.
Yeah, the on group first, yeah. When you finish, let me know, all right?
Detalhe, antes beira.
Mhm. All right, for those who are on YouTube, I'm not sure if you can the see the if you're using a device, you can just zoom in and you'll see the information is on this on your screen. You can go ahead and create your frequency table for this. right? It's a lot of information there. Okay, just screenshot that. You know that'll work for you. Good?
Sir, me almost finished, but alright.
Okay, good. You almost finished drawing the frequency table for this?
Yes, sir. The ungroup one.
Okay. All right. Okay. Okay. That's good. Let me allow you to do that.
Like that.
Sir, I can continue.
All right. So you finish?
No, sir.
All right. Just screenshot it because I'm gonna move off the syllabus we really have focus on. All right. So for those of person who doesn't know what a frequency table looks like, let me just quickly show you. Okay, so for those persons who not so certain what a frequency table looks like, so let me just give you a visual example of a frequency table. Right? So here's an example of a frequency table right here. So a frequency table illustrating ungroup data. But what does this table tell you? The table tells you, for example, these are the scores. But based on the other list of data that you saw, run the raw data, just ungrouped, what they would do is write down from the lowest figure to the highest figure. And then they would record the number of times that figure appears in the list. Good. So a frequency table basically helps you to organize data as shown. Right? Now, all right. So it continues to say now, determine the class features for a given set of data. So when you talk about frequency table and grouping the data itself, that's what we refer to class interval. Good. Now, so we have terms such as class interval, class boundaries, class limits, class midpoint, and class width. So we'll look at that. That's what this is all about. Good. Okay. Now, class interval. Let's look for a proper definition of class interval. All right, quickly. Class interval. All right. Now, in statistics, a class interval is a range of values used to group data for analysis. It's a range of values. So, for example, here we have a frequency table that shows grades, tally, and frequency. So here you can see that you see the arrow, the range. So from 66 to 75 is a range. From 76 to 85 is another range of values, 86 to 95. These are the class intervals. Good. Now, so yeah, so back to the definition. So there's a range of values used to group data for analysis, helping to organize and summarize large data sets. Good. All right. Now, that's class interval. The class boundaries now, you have upper class boundary and you have lower class boundary. Now, when we talk about how to get the upper class boundary, you'd have to minus, well, add 0.5. So for example, let me demonstrate using this. All right, let's demonstrate using this itself. Now, perhaps this will be better. See if I can go straight to this. Right, so that's visible enough, Kelly. All right, so let's talk about the class boundary now. How we go about with the class boundary. So we're focusing on this frequency table right here. Now let us say that we're looking at the class interval 10 to 19. The upper class boundary, you'd add 0.5 to, you'd have at 0.5 to 19. So it become 19.5. But the lower class boundary now, you'd have to subtract 0.5 from 10. And then that would be 9.5. So the upper class, so to get the boundaries, is where you're adding 0.5 to the highest number here and subtracting 0.5 from the lowest number here. All right? Good. That's class boundary. Now, the class limits, basically the same thing, right? But let's look for the definition to be on the safe side. Class limits. Now, in statistics, class limits is define the boundaries of a group or a category within a frequency distribution or histogram. They are the smallest and largest values within each class. Good. So the lower class limit is the smallest value, and the upper class limit is the largest value. So in other words, then, in this case, where we have 10 to 19, so the number 19 in the class interval 10 to 19, the number 19 would be the upper class limit, and the number 10 would be the lower class limit. All right? Now, so we're going to go to class midpoint. Now, to find the class midpoint, you can subtract, find the difference between the class limits, and then divide it by 2. Hence, midpoint. So you find the difference between the class limits, and then you divide it by 2. The class width, it is the difference between, well, let us look for some definition. It's actually the difference between the class boundary the class width, in statistics, of course. Now, in statistics, class width refers to the range of values within a single class in a frequency distribution. It is calculated by subtracting the lower class limit, as mentioned, from the upper class limit. And that's how you get the class width. All right? So the class width, for example, in this case, is 9. So you subtract lower class limit from upper class limit. All right? Good.
All of them, so you then divide them by 2, add them up and divide by 2.
What do you mean for all of them? What do you mean?
So every class limit, like from 10 to 19, from 20 to 29.
All right. To answer the question, the class limit is the difference between the upper class limit and the lower class limit. The upper class limit in the first one is 19. The lower class limit is 10. So the class width is the difference between both class limits. So you take 10 from 19, left you. And it's the same thing for each of them. You take 20 from 29, still 9. So the bottom line, the class width is 9. Good? Got that? All right.
Yes, sir, me get it.
Good question. But the class midpoint now, all right, let's look for the definition. Just to be on the same side, all right? Now, the class midpoint, also known as the class mark or the class mid value, is a value that represents the center of a class interval in a frequency distribution. It's calculated by averaging the lower class limit and the upper class limit. As I told you before, you add the two of them, they divide it by 2. Is that clear?
Yes, sir.
Good. All right. So basically, if you're using the syllabus, there's a technique you could use. You could find the definition of each of these terms, and just by getting the definition, it tells you how basically tell you how to work it out. Right? Now, if you're going to construct statistical diagrams, pie charts, bar graphs, line graphs, histograms, frequency polygons. Now, the pie chart really, of course, is a circle. But when you're constructing the pie charts, you would have to find the sector angle that represents each data or group of data collected, or whatever it is, data that you're working with that requires you to use a pie chart, because it's not every data that you can use to represent the pie chart. Good. Now, if, for example, let's say you have you have 24 hours in a day, but you have 8 hours in the work hour, 9 to 5 in normal refer to it as say you have 8 hours within that time. Now, you might say what percentage of the 8 hours you use to do particular tasks. There is a pie chart to illustrate how you organize yourself for the day. So you know the X percentage of the day or of the 8-hour work day, I used to do this and I used to do that. You can even when you're studying, what percentage you use, what percentage of your time is spent on doing this or doing that, etc., etc. Right? What percentage of time? Yeah. So in this case now, you have to know which situation is best when you're constructing a pie chart. However, other thing you need to know, you have to know how to, if you're going to construct a pie chart, you know a complete circle is 360 degrees. So therefore, you have to take, let's say, you'd have to add up, you'd have to find the total. So in this case, the total is 8 hours. And you want to find, let's say you spend 2 hours on, say, English language. Therefore, it means then you'd have to write 2 out of 8, which is a quarter of 360 degrees. So 2 out of 8 would be 25% of 360 degrees, which would be 90, which would be a 90-degree sector. So the 90 degree would represent that amount of hours that is spent on, say, English. But let's say now we spend another 3 hours now on mathematics. So it'll be 3/8 of 360. So you have to divide the 360 by 8. And then what you get, you multiply it by 3. And then that will represent now the angle from the pie chart for mathematics. So now you'd have already covered 5/8. You're left with now 3/8. Probably 1/8. 1/8 now will probably go to another subject area, another one to complete the full 8 hours. Right? So you have to know definitely when to choose to use a pie chart. Right? Now the bar charts now are frequently being used. The bar chart can represent, let's say for instance, you might talk about shoe size. Shoe size. A different person in the class wear different shoe sizes. And so you put the shoe sizes on the x-axis, and then you would put the frequency on the y-axis, and then you would know what each column go up to. So a bar graph, for those who don't know what a bar graph looks like, let's look at a bar graph. Bar chart, whichever one. So here's a bar graph. There are several bar graphs. So here it is. You're using a laptop. You're using a laptop, Kelly?
No, sir.
Phone. I'll spend much time on this one because you think it's best to spend time doing the work itself, right? All right, so here it is now. So I have the bar graph right here. So you realize now to put February and then to put the rainfall in inches. Good. So you know what the rainfall is. This is discrete. This is basically for numbers. Good. This is continuous, even though it's whole number, but it just keep going, going, going. All right. This now is really a histogram. Even though it's a bar chart, but it's really an histogram. All right. So that's really what the bar chart looks like. Good. All right. So line graphs now, as it suggests, they use lines instead of bars. All right. And histogram knows where bars really come close together. The frequency polygon now is basically the link between is when you put two graphs combined together, which is the line graph and the histogram. All right. Now, so determine the measure of central tendency for raw and ungroup data. Now, the mean average is a way to find the mean average. Now, when you find the mean average now, it's the same like finding regular averages. Same like finding regular averages. Good. So the mean average, let's say for instance, there are 6 persons in the classroom. And you want to find the average age of the 6 persons. You add up all the ages and you divide it by the number of persons in the classroom. That will give you a mean average. You can also multiply the data by the frequency. Good. Let's say, for instance, let me show you. Not that one. We're looking for the one for ungroup data, right? So let's see. All right, here it is. Let's look at this table right here. So if you want to find the mean average with ungroup data, you multiply the age by this age here by the frequency. And to multiply each of these numbers by the corresponding frequency. And then you add up everything and then you divide it by the total number of frequency. That gives you the mean average, right? Understand that, Kelly?
Yes, sir.
Now the median, they might give you not a lot. Median, well, if you do find the median based on the group frequency, you'd have a construct what we call a cumulative frequency curve, and you then draw a line from, you find half of it, half of the frequency, and you draw a line to the curve and come down the curve, and you'll be able to find the median value. Now, otherwise, if ungroup data now, it is the middle number. Good. Now, if you have seven numbers, there is a middle one. So the first three, last three, then the middle one will be the median. But you have to arrange the numbers from smallest to largest, right? Now, the mode is the easiest average to find. The mode is the one that has the highest frequency. That is the mode average. Good. Yeah, drop off. Or I'll go on for tonight, yeah. We're not going along with them tonight, you know. But then we'll do the course.
Sorry about that.
Yeah, man. Oh, I'm saying internet drop or the battery.
Internet drop.
I know. I could have bad day for class today. All right. So, all right. So basically, I have an understanding of that, right? Now you
Yes,
want,
sir.
yeah,
You mean at the average, right?
they're all averages, mean, median, and well, the
Yeah,
video
but
is here for you to watch. So basically, when you watch the statistics videos, that now would be, I mean, that would be, that would be okay. All right. So number 7, to determine when it is most appropriate to use the mean, median, or mode as the average for a set of data. It's all depending. So for instance, you're a salesperson and you want to know what is best to buy. So you're going to do a market research to find out which product the people in the community prefers. So you use a modal average at the mode average at that time, because the mode average will tell you which one they must invest in more. So you invest in the one that has the highest frequency, because most persons prefer this product, so I'm going to spend that. That's at that time you use the mode average. Let's say you have a class, you want to determine a pass mark. At that time, you might want to use the mean average to determine what should be a pass mark. All right? Good. Now, the other terminologies used in statistics: range, interquartile range, semi-quartile range. The range really is the difference between the highest and the lowest recording data. So you find the lowest data, for example, in this 100 different temperatures, you're going to find the lowest recording data and subtract it from the highest recording data to find the range. All right. The interquartile range now, and I tell you, everything that I'm explaining is start in the videos that I create. So I'm just basically giving this as an overview, showing you how you can use the syllabus to revise without using past paper questions. So define interquartile range. But just by knowing the definitions can work the trick. But the interquartile range is all about figuring out the difference between the middle of the first half and the middle of the second half. Right? difference between those two. So let's look for a definition. The interquartile range is a measure of statistical dispersion that represents the range of the middle 50% of a data set. It is calculated as a difference between the 78th percentile, which is the upper quartile, and the 25 percentile, which is the lower quartile of the data. So to find the interquartile range, naturally you're going to draw a curve. You're going to draw a curve. This has to do with the cumulative frequency curve. So normally when I ask you about the IQR, you have to have a frequency curve. So you find the 75% upper quartile and the 25% lower quartile. When you find those two results, you're going to subtract them and you will get the interquartile range. Now the semi-interquartile range is basically half of the interquartile range. All right? Good. So if you're asked to find the semi-interquartile range, then you have to find the interquartile range before you can find the semi-quartile range. All right, as I said, this is just an overview. All right, so construct a cumulative frequency table for ungrouped and group data. Now, if you notice with the syllabus here that I'm using, once you're able to do each of what the objectives say you should be able to do, then you don't have a problem in the exam. So I would find out if I'm using the syllabus as a student, I would say to revise is a good instrument for revision. So I'd say to myself, how do I construct a cumulative frequency table? How do I do it? So because you'd have watched the videos, you'd have done some work, when you come back to the syllabus for revision now, you say, all right, then you can write out the steps. How do I construct a cumulative frequency using ungroup or group data? Right? And then you'll be able to draw the curve. Good. So basically, all right, probabilities now. All right, so we're gonna stop here though. The whole idea of using the syllabus tonight as a guide is to show you what we might have to do for homework. I did this before for HSB students. You would take time out and use objectives as questions, and then you write how you do what, and then you'll make a presentation in the class. So I might as very well ask you guys to do that for an assignment as well, okay? All right, because once you can answer those objectives, you know, and know how to do certain things, you're ready for the exam. Yeah, I feel must pass. Get it, Kelly?
Yes, sir, I'm listening.
Good. So since that you are the main student will come online most time, or who have experience, you know, because it's just a fact. I am going to let you take on the task of preparing some answers to answer the question. You know, to find the syllabus online, right?
So I can submit.
Let me see if we can download it and send it to you. So I'm going to send it to you by WhatsApp. I'll just send it in a WhatsApp group and then tell each person the need for the vote. All right, so what you're going to do, with the syllabus. All right, so we're in the live right now, folks.